How and why is the equation for the area of a circumscribed polygon different? Well, first off, we can just look at the equations for an inscribed polygon and a circumscribed polygon, and we can see the difference in the equations. So you can see here that the area of a polygon of n sides inscribed in a circle with a radius 1, the equation is going to be n times sine of 180 divided by n times cosine of 180 divided by n. And if you look down here, then you can see that that's very different from the equation of a polygon of n sides circumscribed around a circle with a radius 1. That's going to equal
n times tangent
over n.
of 180
But I think
divided by n.
an important piece of this is shown more clearly here. You can see that an inscribed polygon is always going to be less than the area of the unit circle. This makes sense because the unit circle has radius 1, and you can see here the triangle with 3 sides takes up less space of the circle, and as you get more sides you're getting closer and closer to the area of the full circle, which is the area of the unit circle. And this is different with the circumscribed polygon because that's starting outside the circle, so that's always going to be greater than the area of the unit circle, because I mean there's only 2 shapes here, but that still illustrates what's occurring, because the triangle here has got lots of space around the circle, and here the more sides you add, there's far less space around the circle, so you're going to get closer and closer to the area of the unit circle. So solving the problems, this shows how I first started. I saw that it was much easier if you broke down the triangle within the circle, and you can see here when I've broken it down that the triangle it becomes a 30, 60, 90, and then by using the area of a triangle equation, 1/2 base times height, you can see that sine of 60, so using our SOHCAHTOA skills, sine is opposite over hypotenuse, so opposite 60 is this side over hypotenuse 1, so that would be the base, but because there's 2 of those, we'd have to go the base equals 2 times sine 60, and then the height would be the cosine of that, because once again our SOHCAHTOA skills, cosine equals adjacent over hypotenuse, so that would be the height equaling cosine of 60. And then the area of the entire triangle, because the 1/2 base times height, that would cancel out the 1/2 and the 2, so you're just left with the area equals sine of 60 times cosine 60. But you're not quite done yet, because you still have 3 pieces of those, so the final area would equal 3 times sine of 60 times cosine 60. And this is a very different process for the circumscribed. You can see here the difference once again between the circumscribed and inscribed. You're going to use the same method, pulling out that triangle and breaking it into pieces. So I've got the same equation as above, and but the base is going to be something different here, with the tan equaling adjacent, or opposite over adjacent. Then we can see tan of 60 opposite over adjacent, then that would equal the base, so if we multiply that by twice we have that, and then the height is given because we know the radius of the circle, and so then by plugging that in we cancel out once again. The area of the individual triangle is tan of 60, but then multiplying it by 3 tan 60. So I hadn't really noticed any patterns just yet, and it wasn't really until I got to the five-sided polygon that I noticed a pattern. So you can see here I did the same thing, pulled out a triangle, broke it up, and when I solved this out, once again, that's when I really had an aha moment, because by looking at my table, I began filling this in, and this is when I saw there was a consistent pattern between each of the polygons, and that allowed me to figure out the equation for inscribed and circumscribed polygons. And my main question at the beginning of the lab was to understand the relationship between the number of sides of a polygon and the area of the inscribed or circumscribed polygon. And I thought that was really interesting, and looking at it first, it was pretty confusing to me to understand it, but by using my previous knowledge of the unit circle and how the radius is 1, and now that I can see it, it's actually pretty interesting to me to understand that now. You can see that the number of sides increasing is going to get closer and closer to the outside of the unit circle. And then also the opposite down here. The area is always going to be greater when it's circumscribed, and it's always going to be less as it's inscribed. And it was kind of hard to believe, especially looking at the 10,000 and the 1,000, that it would get so close. But you can see here, it's really just getting as close as it possibly can to pi, but it's not quite going to reach it. And I mean, now that makes sense to me. So that was one of the questions of the lab that was very intriguing. And also it was crucial that we used our previous knowledge and our problem-solving skills, breaking down the triangles into special triangles, using our knowledge of SOHCAHTOA, and knowing this sine, cosine, tangent. So definitely it was crucial to use the problem-solving skills to be able to derive these equations. And overall, it was a fascinating lab.